Hey, this is Don from Padlock Technologies again with another video. This video is going to be based on an email request I got, request a bid at padlocktech.com about BGP Confederation. So, if you don't know anything about BGP, especially from an IBGP perspective, there is a full mesh requirement, and there's two ways to tackle it. One is a route reflector. So you can have route reflectors in your BGP environment, but route reflectors do come with a certain con, which is suboptimal routing, because the best path selection is based on the route reflector's point of view and not the PE's, wherever it is in your environment's point of view. Unless you're doing something called optimal route reflection, I'll put a card over this way on optimal route reflection, or it'll probably cover my face or something like that. So you can learn about optimal route reflection and what is the benefit of using that with route reflectors to kind of get over that con piece. But today we're going to talk about confederation. So confederation is the second way to handle the BGP or the IBGP full mesh requirement. If you don't know what that is, the formula is very simple. It's n times n minus 1 divided by 2, right? And that's the same formula. I said this a bunch of times about symmetrical encryption. It's the same formula, right? So n times n minus 1 divided by 2. So you can see where that's going to be a problem if you have, a lot of routers. You can end up needing like hundreds of BGP peerings to satisfy the full mesh requirement. Route reflectors eliminates that because it has certain mechanisms to prevent loops, right? And confederation also prevents that by basically forming many islands within one big island, right? So one big ASN will have sub ASNs in it or sub ASs in it, right? So if we look at this diagram that we got here, we have the main AS is 20010, right? Within that AS, though, we have sub ASs, which are 2007, 2008, 2009. So you're going to form a eBGP neighborship or adjacency in its respective sub AS, but to the outside world, which is, AS 2001, 2, 3, I don't know why that just came up, 3, 4, 5, and 6, they're going to pair with the main AS, which is 20010, right? Now, within the sub ASs or the confederations, you're going to see a certain the way the AS path looks, you're going to see parentheses over the confederation peers. So you have the confederation ID, which is the main AS, which is basically what you're going to be peering on the outside, and then you have your confederation peers, which are the sub ASs within the main AS, right? So when you look at the AS path, when you see the sub AS, or the subgroup or sub ASs in the AS path, you're going to see a parentheses over them, right? So if I wanted to go to router 12 from router 14, your router 14 will see 20010 and then 2001 in the AF path. But if I do it from router 8, it's going to see 2007 and then 2001, right? So this allows you to do like your EBGP route manipulation, stuff like that, weight, local preference, best path selection stuff. You can do that within the main AS. You could technically do it with the route reflectors, but this gives you a little bit more control because you can determine which way you want a certain path to take. So what is the main configuration here? Well, the main configurations in confederation is going to be the confederation ID and the confederation peers. So from router two's perspective, which is right here, router 2, 3, and 1 are going to be forming eBGP relationships. Now the underlay IGP underneath that is ISIS. 1, 2, and 3 are level 1 and 2 routers, and then the other routers within the sub ASs are level 1 routers. And if you want to think about that, think about level 1 when it's attached to a level 1 and 2. Think of it as a NSSA, right? Because I'll show you when we go to one of the other routers. Technically, underneath the hood, when you do that type of level 1, level 2, and then you have a level 1, the level 1 router would have a default route that says just go to the level 1, 2 router, right? So it's the NSSA because you still do redistribution, unlike OSPF with a stub area, you can't. Um, but what we're doing from a BGP perspective is I'm using the next hop self command. So all the traffic for its respective sub AS will go to either 1, 2, or 3. So let's look at the configurations here. So I'm not going to bore you with the IGP stuff because if you don't know ISIS, I can create a video about ISIS, a quick, brief ISIS, but mainly this is going to be just underlay reachability, and we have BGP over the top. I'm not going to bore you with the underlay stuff. So if we go to show run router BGP, I like to do my templates, so I'm going to go through and just go through everything here. So number one is for IGP. You see we have the route reflectors and the next hop self, right? So this is to tell the routers within my domain to come to me when I want to go somewhere else, right? Then we have our, that's a peer policy. We have our peer session, just session information just to start the session. Then we have router 3 and router 1. Since I'm doing it off the loopback, we have the eBGP multi-hop. And then we have our just AS, remote session information. And then we go down to BGP. We got our router ID, but here's the kicker here. So these are the two configuration commands for BGP Confederation. So we have our confederation identifier. This is what is going to be ultimately what the outside AS peers to, right? So when you have ASN 2003, they're going to peer to 20010. They're not going to peer to 2009, right? Because technically they're not supposed to be able to see that AS in the AS path, right? And then my confederation peers are going to be the sub ASs on the other side, which is what is this, 2? So this is going to be 8 over here, which is ASN 2008 and ASN 2009. So now when we go look at when we look at the AS path, or when we look at a route in the BGP table, and this is IPv4, by the way, this is nothing to do with VPN-v4, we will see if I wanted to go to ASN 2005, we will see in parentheses 2008 and then 2005, right? Now, if I wanted to do like local preference or anything like that, I can manipulate it on router 2 to say, hey, I might, let's say I wanted to do something, I put a stronger weight from 2 to 3 compared to, or a stronger weight from 2 to 1 and not 2 to 3 for anything going to ASN 2005. So then the AS path, instead of going from 2 to 3 to 8 to 5 to 14, sorry, it would go 2, 1, 3, 8, 14. No reason to really to do that, but it gives you the option to do it. So now let's look at the BGP BGP IPv4 table. So show BGP IPv4 unicast. And as you can see, this is what I am talking about here. So if I wanted to go to the loopback of router 14, which is here, you see that 2008, which is this sub AS, is in parentheses and then 2005, right? If I wanted to go to 10 or 11 from router 2's point of view, I can either go to, what's the best path? So the secondary path here would be, it can go to 8 sub AS and then 9 and then to router 10, or the preferred path is just goes directly to 9 and then to 2003. But as you can tell, with these sub ASs, you are going to see these parentheses, brackets over it, right? To let you know that you're in confederation. Normally, and when you just do BGP normal IPv4, you will just see the AS path and that's it. But once you start doing confederation, this is what it's going to look like. But to the outside, we're going to use router 10 here. To the outside world, let's say I wanted to look at my BGP table here, and we'll just look at just the whole table here. So show BGP. As you can see, to get to router 14's loopback, we do not see the sub ASs in it, right? We only see the main AS, which is 20010, and then the other AS where the route is is going to, right? And that's the benefit of Confederation. You do not see the sub ASs. There could be 20, 40, 50 sub ASs in a main AS. But to you, as the CE on the CE side, you only see the big AS, right? So you don't have to worry about, even if you do a trace route, you're only going to see, you'll see if they don't turn off IP TTL propagation, if they don't turn that off, then you can see the internal going through, but you'll never see the different AS numbers, right? So we'll actually do this now. So just to validate that we can ping, we're router 10. So we're going to do 214. Source for the loop back just to show you that reachability is there. So then when we trace route, so we're going to watch the trace route here, and you'll just see it go through. Now that Confederation ID and Confederation peer has to be on every router within the main AS. If you do not have that on one of the routers, you will not see the parentheses for the sub ASs in your AS path. So every router in your main AS that's going to do Confederation needs to know what the Confederation ID is and what my Confederation peers are. So this looks like it went to 14, went to 1, probably going to go to router 3 instead of going to 2 and 3, and then that's going to go to 8 and then 14. Yep, router 8 and 10 1 10 1 is router 8's E00 interface. And 214 1, and then hits the loop back there. But the main thing I wanted to show you in BGP Confederation is from a BGP perspective. Like if we just go show, now I like doing it this way, but you can do it the other way as well. Unicast, and then we'll do 10 14/32. So you can do it another way too, but once you get used to doing just show BGP, the show IP BGP, I kind of just stopped doing that after a while. But as you can see, it's being advertised from my direct neighbor, and here's the AS path in here, right? So as you can see, it is not showing you 2009. It's showing you 20010, right? The main AS that's up here. And again, in the real world, which one would you choose? Well, this one is a depends, right? Um, do you want to have the same like path selection stuff that you can technically use with normal EBGP, stuff like that? Yes, I would go with Confederation if you want to do that, right? Because from an IGP perspective, you really only messing with local preference at that point because local preference is domain wide when weight is locally significant. You're really not playing around with EGP like manipulation stuff, right? Now, the route reflector is the easiest configuration, but again, it comes with that suboptimal routing situation where it's, hey, I'm going to be giving you a path based on what I believe is the best path. Now, this is where you have to worry about route reflector placement, because if you put the route reflector in a bad area, well, the best path to get out to the next AN may be sitting right next to you, but because the route reflector thinks it's a router all the way on some other side of the network, you're going to send traffic all the way down to that best path instead of the best path that's right in front of you. And that's the problem with route reflectors, unless you're doing optimal route reflection, which will take you as the route and then say, okay, based on where you are, your best path is actually over here, right? And then you can get around the issues with normal route reflection. But this is BGP Confederation in a nutshell. It's just another technique to get around the IBGP full mesh requirements and the hassle that can get to if you have a lot of routers. Hope this video was informative. If you have any more questions, there's going to be a video bumper at the end where you can send your questions. If I can answer it, because I know a lot, but I don't know everything. But if I can answer the question, I'll make a video just like I did with this video that you're watching now. This is Don from Padlock Technologies. Don't forget to share, comment, like, and subscribe. Thank you, and have a nice day.